Before I dive into doing the alignment, I'm going to show you the equipment I'm using and how it's hooked up. So, for one, we need an RF generator. Now, I could have fired up my HP 8657A, but that is gross overkill. Or I could have fired up a vintage one like that old Philco back there, which actually hasn't been restored yet. But we really don't need anything all that fancy, as long as it's accurate. Well, I also happen to have this universal video generator handy, which has an option for 4.5 megahertz, so that's what I'm going to go with. These things show up on eBay rather inexpensively all the time now, because for most service techs they are utterly obsolete and useless now. It's a VG91. A lot of nice features in this guy. Alright, so where does that go? Well, following the instructions, it says to inject it into the grid of the video amp through a 1000 picofarad decoupling cap. So I've got a going BNC cable that terminates in 2 alligator clips. The negative lead is going to B minus, not the chassis. Remember, the chassis on this is sort of a floating virtual ground. It is not the return B minus of the power supply. Well, here is the video amp. Bottom of the tube right here. There just happens to be a loop right here, which is ground. And I gotta think that's not a coincidence. So you can very conveniently just clip the lead onto here for the negative. Now the positive, well, that goes to the grid, which is pin 1, which is this junction right here, 1 meg resistor and this 0.1 microfarad cap. So that's this red lead coming down here, going through 1000 picofarad cap to the generator. Now, if you want to do things really nice and clean and accurate, this is a little sloppy. You should use shorter leads, don't have things kind of flopping around unshielded like this. But for demonstration purposes, I wanted to make it very clear how I've got things hooked up. Now, for the meter, well, I'm using a VT-VM. You want something that's high impedance. You could use a digital multimeter, but when you want to peak something, it's easier to watch an analog meter. As I adjust the coil, you're going to see the needle go back and forth, and it's easy to get a peak. On a meter, you can do it, especially with something like this Fluke 27, because along the bottom it's got a bar graph. Let's see, kind of peeking up a little bit there as I change modes. But its refresh rate is a little slow, but in a pinch you could make do with something like that. Otherwise, if you've got a plain old meter like this, well, you just got to look at the numbers and adjust things very slowly and try to get the highest reading you can. Now, as far as how it hooks up, ground, again, going to B minus. The positive lead of the meter is going through a 10 kilo ohm decoupling cap to, they say, either side of the 10 microfarad electrolytic in the ratio detector. I imagine, depending on which side you put it, your needle's going to deflect positive or minus. Most VT-VMs have a minus volt and plus volt. So as you're adjusting it, it should be pretty clear whether your needle's getting pegged past 0 or it's going up into the positive direction, and just flip this to whichever polarity makes sense. Multimeter, well, they can handle positive and negative no problem automatically, so you don't have to worry about it. I have disconnected the CRT, and I got a dummy load resistor in place of the filament, so the set will power up. And it's a good idea to tape off the speaker leads, otherwise they could short against each other or the chassis. But before you do the alignment, you should let this chassis warm up for a while. I'd say like 15 minutes or longer. But also a good idea to stick around while it's running in case anything goes wrong. So I'm going to get this guy fired up. Also with your test equipment, so I've had this on for a good half hour or so. Not as critical to the meter because we're not going to be looking for an actual reading, just a peak. So we're just going to be looking for how that needle deflects, not the actual number that it's on. But still a good idea to let it run for a while. And likewise, your signal generator. Modern digital one, they stabilize pretty quick, but if you're using a vintage tube-based RF generator, again, let's say at least 15 minutes to let it really warm up and stabilize. Alright, let's give this a whirl. So, 4.5 megahertz, lowest range, lowest RF output level, and I notice my meter is deflecting off to the left. So, as I'd mentioned, I may need to change the polarity, so now we're positive. I'm going to turn up the level on the generator a bit and see if that needle moves. Yes, it does. Very good indication that I've got things hooked up properly. Now I want to use the lowest level possible to not overdrive things. So I got this in the lowest range. I'm going to turn up my output level in the generator until I'm about mid-scale. And now adjust the coils. I use one of these insulated adjustment tools. Plastic tube. With metal bit in the end, which fits onto the slotted, threaded coil shafts. So there's two down in here, a little hard to see, but, well, the big one's easy to see, it's that guy right there. The one to the right of it. So that guy right there, that's the video amp. That little guy there, that's the pick-off coil. And then there's the main transformer. So first I'm going to do that little guy down there while watching the meter. So I'll get my tool on that shaft there. There we go, and tweaking it. And it was not really off. About there. I really didn't need any adjustment at all. The other one's got to be off because I think somebody else messed with it, and for sure I messed with it, so it's got to be wrong. So, here we go on that guy. Oh yeah, that was off. And now I'm going to lower the output of my generator to keep this approximately mid-scale. Curiously though, I'm having to back the shaft out even more than I was to peak it. So, about there. So you can see it's out pretty far, but hey, that's where it's peaking at. And now I need to change where my meter is hooked up to do the final adjustment when we want to null the meter. Okay, now we want to move the meter to, well, one side of the wiper on the volume control, which if you follow around comes right here. It's going to one side of this 33K resistor, so this guy right here. And yeah, that's off quite a bit because it should be down at 0. Now one trick you can do with meters like this is, I'm going to disconnect this for a moment, and I actually want to short the meter out. Notice there's a 0 minus plus on here. Well, ratio detectors, you want to null, and if you adjust the coil a little bit to either side, it should swing plus and minus. So one trick is you short out the input and use the 0 adjust to get the needle so it's actually at halfway deflection when no signal's applied. Then hook it up for that and get it so that it dead in the center, and if you tweak the coil, rock the coil a little bit, it should go plus minus symmetrically around it. So if I short this guy out, again, this is very sloppy work, but just demonstration purposes here. And adjust this. Right, and now hook it up back on that point. Yeah, now we can see how far off that is. It's supposed to be dead center, and it's clearly way off. So now we adjust the bottom of that big coil, which is this guy. Right, yeah. Very easy to adjust. Easy to swing it back and forth. I want to get it so it's right on the money. A little bit of tweak one way, a little bit of tweak the other way. Perfect, just like it's supposed to work. So right about there. Alright, now I'm going to disconnect my stuff, and I'll just use this guy right here and switch over to using it as an RF generator. Or, you know, on a, I should say, a test pattern generator with a test tone, and feed it through the antenna input, and we should hear a nice clean tone coming through. Well, got a little bit of a problem. Don't hear anything, do we? Or just barely. Till tune off the station. So, same problem as there as before, but now even more so, because the sound is booming. So, what does that mean? The video is messed up. And when I look at the video IF coils, I can see they're shiny towards the bottom for maybe 1/4 of an inch, which means somebody monkeyed with these as well. So, simple thing I can do, I can see, bam, 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 I can see exactly where, well, they're not shiny anymore, so got nothing much to lose now. I'll just kind of put them back down to where the shiny disappears and see what effect that has as I do each one. And then, yeah, I'll have to get out more test equipment and do the video alignment. I say more, well, different. Now I will have to use this, because this does not do the old IF. This still is for the 45 megahertz IF system. Let me see all the frequencies it does here. Well, this needs more like 21, 22 to 26 megahertz, so I'll have to use that guy. Anyway, dim the lights a little bit so you can more readily see the effect as I tweak these. So it's good where we have good sound, and maybe magically the picture will get better as I turn each one of these in. So there goes that guy. And here comes the next one. Well, it certainly had an impact. One more to go. Well, let's see if I adjust the fine tuning. Well, definitely, it's not working. I don't seem to have quite as much gain as it did before. But the sound and good picture are kind of more in alignment now. At least when we have the best sound, we have some sort of image, so that's promising that I'm on the right track. So, somebody must have monkeyed with these. Now, I still have no idea what somebody was trying to accomplish with that switch for the ham and, you know, who knows what, so... They may have intentionally detuned these to receive some other frequency. You never know. So yeah, I mean, if you want to be brave and try adjusting these by ear and by eye, be my guess, but I think it's pretty foolish. Even if you get something that looks okay, it's not going to be as good as it could be with proper test equipment. At least we're heading in the right direction. Yeah, not so hot. Picture's not got the greatest definition. But we do have pretty good sound when the picture's decent, so that's an improvement. I don't think the picture's as good as it was before I started monkeying around with this.
It couldn't have been anyone but Sam Burns. He said he didn't hear the shot, so it couldn't have been Carlin. The scream came well after the shot, so it couldn't have been Marion Keats. And Mrs. Adrian...
Alright, enough messing around. We'll get set up for doing the video alignment properly. Alright, so let's see if I can do a proper video IF alignment. So RF amp, mixer oscillator, and then here are the 3 IF stages. We've got 3 IF coils up here, and then there's one more below this box, so those are the 4 I want to adjust. Now with some designs you can do a pretty decent alignment with a fixed RF generator and a VT-VM, similar to how I did the audio, but not so with this design. You really need to use a swept RF generator and a scope. So, well, yeah, got a little bit more equipment out here now. So, what have I got? RF generator for marker, scope to see visually the response of the IF, and then a sweep RF generator. Now this is all fairly modern equipment and most definitely overkill, but it's all reliable and I'm familiar with this equipment. This is a scope I used in college. Yeah, it's more than 20 years old now, but easy to use, pretty reliable scope. This is a great RF generator. This is one piece of equipment I definitely splurged on. I wanted to have an RF generator I could just turn on, dial in the frequency, and it just works. But this doesn't do sweeping. It just is fixed RF, and you can do AM and FM and I think phase modulation. Lots of good stuff. Great frequency range, goes up to 1 gigahertz and all the way down to 0.1 hertz. Great RF generator, but you can't sweep. So for that, I need this guy, which is a sweep generator. Dial in the center frequency, and then this sweep width controls how far off of that center frequency it will deviate. Got a coarse control here, and then a variable control here. These squiggles you see on the screen here are the markers. So since I've built in markers, but they are fixed at 1, 10, and 100 megahertz increments. If it had a variable marker generator, I would not need this at all. Now if I want to go old school, I do have some old sweep generators like this guy. Same concept, same basic functionality. Set your center frequency on the left, set your sweep width, and this has a built-in marker oscillator. So this has got it all in one except for the scope. For that you need an external scope. Or, if you really want to go all in one, this Philco 7008. Set your center frequency, sweep width, marker generator, and it's got a built-in display. However, this needs to be restored. And the other issue with using vintage equipment is got to maintain it, got to periodically calibrate it, got to let it warm up. This stuff, just turn it on and it works. And well, I'm not going to say I'm lazy, but I'm practical, and I don't have all the free time in the world, so I do like to use modern equipment now and then. So, as I vary the sweep width, notice these little squiggles get closer together and further apart. I'm saying the sweep width. So we're supposed to set the center frequency around 25 megahertz and set it for about a 10 megahertz sweep width. So we do that, and I can tell it's 10 megahertz sweep width if I see 10 tick marks on here. And if I want to make my life a little bit easier, if I get everything set up right so that these markers coincide with the grid on the screen, and I know it's all 1 megahertz increments, like 20 megahertz, 21, 22, 23, 24, 25, and so on. And if I do that well enough, I can kind of get away without using a marker generator at all. But some of the frequencies they want me to dial in are a little bit oddball, like 22.1 megahertz, so it can be nice to have this. Also helps to double check the accuracy of these markers with an external generator. So I'm going to go through and get this all set up. I'm going to have to tilt this thing back on its side and hook up stuff down below. And so I tried doing an alignment visually with the multi-burst generator. Well, we'll see how I did. I should have a response that looks like the inner response there, not the outer dashed one. Oh no, sorry. I'm sorry. It should look like the outer dashed one. That is the response of just the first, of just the 3 AF stages without the converter. That's what we're going to be doing first. So it should have a bandwidth of 22.1 to 27 megahertz. And nice flat response on top. Somehow I don't think that's what it's going to look like. Alright, I got all the equipment powered up and hooked up. So briefly, sweep generator. We got marker going around to the output of the RF generator. Scope, vertical, going to the Y input. Horizontal, going to the X input. RF out, going into the set, and in a moment I'll take the signal from the set and that goes to DMOD in. Simple enough. It's all we're going to use every connector on the front of the generator. Scope is set in XY mode, and I've got this dialed into 25 megahertz, same as this. Why? Well, I want to double check that everything is set up right. So I've got this going to the marker input. I got the size turned down all the way, so that's why we don't see anything on the screen right now. I'm going to increase the size of the marker, and that is that blob right in the middle. Pretty close. I can tweak that. Either I can tweak my scope and move things left and right, or I can also tweak the actual generator output, but I'll leave that alone and tweak the scope a little bit. And then ideally I want to have markers every 1 megahertz, so if I enable this guy, there's the hundreds, there's the tens, and there's the ones. So again, 10. So if that's 25, that would be 20, and that would be 30. That is pretty darn good. If I turn on the ones, it gets a little crazy when there's a blip on every single tick mark there. Few controls for the markers. You can set the width. I can make them wide. And the way the built-in markers work, the 10 megahertz markers are bigger than the 1 megahertz markers. So that's what the largest marker, blob size, the medium, and small. And you can also control the amplitude of the markers. So things are off maybe just a hair. Alright, that's pretty darn good right there. Make them smaller. I'm going to turn off the 1 megahertz. I'm going to turn these off for the time being. Alright, so RF out goes into the grid of the first IF tube, the grid of this guy. And negative lead to ground, and I got a 75 ohm terminating resistor on this. This output of this generator is 75 ohms. And the scoop hooks up to the cathode of the CRT. So very final output after it's been demodulated and amplified and all that good stuff. So actually, right there, pin 2 on the CRT. And it would help if I actually plugged in the probe. Now it says demod. I don't actually need a demodulator probe. I have one that's a probe that has a crystal diode detector inside of it. Because we're using the TV detector, we're picking off the signal after it's gone through the converter and the detector. So we're using the detector inside here, the crystal diode in here. So we can just, basically it's just a straight wire connection. Alright. Well, that sure doesn't look right. Remember, we should be seeing this. A nice plateau. Well, we've got a little hump of a response here, and the rest is off to the side. I'll increase the output amplitude a bit, and yeah, that's a mess. Crank things up even more here. So yeah, got some work cut out for me. Knock the signal back down a little bit. Alright, well, they give you some steps here to help you out. Now, if I didn't have any instructions in just that, I would just have to twiddle these 4 coils until it looked like that, which could take forever. Luckily, they give you some hints, which is to peak L51 initially for a maximum response at about 25, and then peak L36 for around 23. And then adjust another coil so we get a 27 megahertz marker about halfway down on the high side of the response. And then go back to another coil and adjust that. So, peaking the first one at 25 megahertz, and that is L36, which is the middle guy. It's this one right here. So, well, I've already got my marker at 25 megahertz, so I want to mess with that coil to see if we can get some kind of response going there. Right now we don't have anything really. It's kind of flatlined at around 25. This can take a while. Be patient. You're going to have to go back and forth. The coils interact with one another. You adjust one, it messes up another one, and you go back and forth and back and forth. They're starting to get something. So ignore the overall shape. You just focus on that marker and adjust it so that's peaked. Should be right around there. If you keep going, it just starts to slide down a little bit. Sorry, the cable got in the way there. So right about there. So things are actually looking better already with just that one adjustment there. Not the easiest thing to film. I mean, people have asked me to show how to align TVs time and time again. Obviously, there's a lot of equipment, there's a lot of cables, you don't see where I'm doing the tool. I really don't intend this to be a tutorial on how to align a TV. Every TV is different. You got to get the instructions, go through them, familiarize yourself with the equipment and the concepts involved. I just want to give you some idea of how far off this set was, what I'm doing to get it back into alignment, and then we can compare the before and the after. Alright, now we want to adjust this guy for peaking around 23, so I can either put these markers on, and I know if that's 25, that's 24, that's 23. Shift it a little bit on me. Or I can turn these off and dial this guy into 23 megahertz. Ah, I'm glad I did that. So, depending on how you hook things up and the way your equipment goes, the lower frequencies can be on the left side, or in this case, they're on the right side. Well, one thing you can do with this scope is, well, actually I did it to myself. I have invert turned on. How about I turn that off, scoop this back over the other way. That could have driven me slowly insane. Okay, 25, dialed into 23 megahertz, now 23. So now low frequencies are on the left, higher on the to the right. Alright, cool. So, let me adjust this coil so we get that guy peaked. Whoa! That guy's really peaking. Now I could change sensitivity on the scope, but it's better when you're doing alignments to knock down the level of your RF generator and leave the scope settings where they are. I'm also going to move this down a bit, so there's no point in me having all this real estate down here since trace is only going to be going up from the baseline. So again, you just focus on the blip, not that peak, not the peak of the response. Just maximize that marker. So that's right in there. Alright, now we flip over to 27 megahertz. And now we're supposed to adjust it so that this is about halfway down the response. I'm not sure why things got all kind of weirdly modulated there. It's back on 20. Huh. So they mentioned that on here that as you're peaking this, you can get things into kind of a self-resonating state where you start getting some feedback, and that might be what I've got going on here. I can throw in a 1000 picofarad cap between a couple points to try to eliminate that. Something else I can do is I got this marker generator turned up pretty darn high. So I am going to, that took care of it. Harder to see the marker now, but I can compensate for that by just cranking up the size here so I can still see it fairly well there. Things are getting a little jittery again, so knock this guy down, maybe minus 10 dB. Anyways, actually I can just turn this off altogether, because I know 27 is right there. So the overall response is 1, 2, 3, 4. We want this point to be about halfway down the response, so it'll be there. So it's actually pretty close as is. Then the fun part comes, which is doing that makes the overall response higher, so kind of got a moving target here. So I think I'm going to have to go back and forth on this, because as I adjust this coil, I don't think I'm ever going to get it. Well, yeah, I don't think I'm ever going to get this point right here to be half of the overall response. What I got to do is knock that peak down. So now that I've got things roughly in the ballpark of where I want them to be, I need to go back and forth between those three coils. This guy, and then the one underneath this can, until I can get this to be flat across the top with the cutoff points at 22.1 and 27 megahertz. So after a bit of back and forth, I finally get it down to the final adjustment, I think, which is this coil near the detector. So if I do that clockwise, there we go. Pretty darn good. Now notice, yeah, there's less gain, but flat gain across a wide range of frequencies. That's the key. We're dealing with video here. You need a wide channel for all that video info to go through, and then also the audio will be stuck in near one end of it. So a whole bunch of video info and a little bit of sound info at one end. So unlike, say, an AM radio where you want it to get the maximum gain at a very narrow frequency range, like around 455 kilohertz, TVs are different. You need a nice big wide bandwidth. Theoretically, the ideal is 4.5 megahertz. Set like this, they compromise a bit, so we're going from 22.1 to 27. Well, that's 5.1. But as we see now, we're going to back up one stage, which is going to knock it down a bit more. So the overall IF response is actually 22.4 to 26.4, or 4 megahertz. So still pretty darn respectable. I've done later Econo sets from the mid-50s that have more like a 3 megahertz bandwidth. So that's actually pretty good. So that's a 22.1 megahertz marker there, about halfway down like it should be. Increase the input a little bit to get this. So we got 4 ticks, more or less. So yeah, it's right about halfway up, and then 27 megahertz. Oh, gotta work on this side a little bit. It's not quite halfway, but even so, that's pretty good, and it's a heck of a lot better than it was when I started. So let's see. This is where you start going nuts. So yeah, start messing with this, and now the overall shape changes, and I'm losing some bandwidth, and it's not flat across the top anymore. So now I'll go back through and then adjust the other coils and back and forth and back and forth. At some point, you often have to just say, it's good enough, it's as good as I'm going to get it. It's pretty close to the ideal response, and I'll just leave it at that. But I'm going to fight with this a little bit more. Well, I got that IF looking pretty darn good. Now I've gone back one step, so I'm going into the grid of the 12 AT7 converter tube, because there's one more coil that needs to get adjusted in the IF. This one's going to be a little bit trickier, because it's actually, there's a slug on top and there's a slug on the bottom. It says to adjust them simultaneously, so I got 2 adjusters, and I'll be using one in each hand. But look at the response curve I've got now. It's supposed to look like the solid line here. So a little bit narrower, but the same type of wide, flat response. Well, that is not what I've got. So adjust these and hopefully get something better. I'm just going to adjust one of them right now while I got the camera going to see if adjusting these. Yeah, adjusting these does have an effect. So hopefully I can get my nice response curve back, because that sure doesn't look so good. And that would also explain part of the problem with getting good sound or a good picture, but not both, because remember that wide response portion of this is a video, and then the sound will be at one edge. I forget, it's either over here or over here. So if you got a good response, say up here, and then it drops off, you're going to get a decent picture but weak sound. Or, as you adjust the fine-tuning, you're sliding that response over so you get good sound. The video is going to drop off. That's why you got to have that wide response to get both a good picture and video. So I've got to make this be about that wide. It's only about maybe 2/3 or 40% as wide as it should be. That's not going to cut it. After about 15 minutes of fighting with that coil, I think I got things pretty good. So it's supposed to be 50% down at around 22.4 and 26.4. I'm off a little bit, but it's actually a little bit wider bandwidth than they wanted. That's better than too narrow. So I think it's time to disconnect this stuff and do some tests with test pattern generator and a video source and see if we got better picture and sound after all that twiddling around.
He kept the money. He threatened to name me as
Well, it looks like all that hard work paid
I
off.
was afraid. I didn't say anything.
Pictures are much sharper, and hey, we've got a good picture and good sound at the same time.
Mr. Gus found out Kenny had stolen that 100,000. He doctored the books to make it look like he, not Kenny, had stolen the money.
Well,
Why did Kenneth
there is some interference,
That's why he wanted
some
money from the
sparklings.
company assets.
The more I have the contrast cranked up 100% right now. If I back it off, they fade away a little bit.
Using a dummy, of course.
Those company assets.
So I don't know if it's really an issue. Plus, there should be a shield around the CRT, which I do not have installed.
Can you tell me how Kenneth, not an officer of the company, could use them?
One thing I want to try, though, I had a similar issue with another Motorola 7 VT-3 bakelights that I worked on ages ago. I never really got around to resolving it. Well, I got a comment about troubleshooting this to simply ground the grid to the video amp, and if the interference goes away, well, it's likely being picked up somewhere in here or the antenna input. However, if it's still there, well, then it could be somewhere else. Like there might be some corona, some arcing in the high voltage circuitry that's getting into it, or again, improper shielding. So there should be a shield over this, and it is right next to the high voltage oscillator coil, so it does seem pretty good. Possibly there could be some noise getting in over here.
Turn over my share of the Dowgren Associates partnership to him.
So Sandra Dawson
But otherwise,
sanitarium to go to the movies that night.
pretty happy with the operation.
Alone in the office to talk over your problems.
No, Sandra didn't know anything about Kenny's threats or the divorce. She was so desperately worried about Gus because of the
what, Mr. Morley?
suicide note.
Ken was working in the den. I went to hang up his jacket, and I found the note in the jacket pocket. It was sort of a rambling, disjointed farewell to life. The note was typed with a signature on the bottom.
Whose signature?
August Dahlgren.
You may step down.
And here it is back with the white phosphor CRT and a bit of programming. Great picture. Fantastic sound. But we do have some
Are there
interference.
any further witnesses for the defense? Miles? Miles?
Becomes most visible when I turn the contrast all the way up.
No, Your Honor, there are no further witnesses. The defense rests. Very well.
I back it off and turn the brightness down.
At which time we'll hear the concluding remarks to the jury.
And that's still pretty noticeable. Now, I'd already gone and grounded the grid of the video amp, and that interference does disappear.
You'll be all right, son. You'll see. I'll make them.
So, well, one easy possibility is there is this metallic shield in the CRT, which should be grounded right now. It's not going to anything.
Mr. Crawford, are you ready for your summation?
It's crude, but
Yes, Your Honor.
I can grab an alligator clip and simply short it out.
Ladies and gentlemen of the jury, a boy is dead, and men who call themselves the caretakers of human justice are crying out for vengeance. You see them sitting there before you, demanding life for life, all in the name of that blindfolded goddess who stands outside the courtroom.
No difference whatsoever. Could be a little bit of arcing down in the high voltage component somewhere. I tried to leave all the solder connections as smooth blobs with no sharp points, but I could apply some Corona dope to eliminate that possibility. Pretty sure I got all the tube shields in place. There aren't many. One here, one here, and one here.
Thank God that we imperfect human beings have been given such
it could be interference from equipment I've got. Could be coming from the converter box itself. So I could try some other signal sources. Yeah, now that I'm thinking about it, I don't recall seeing this interference when I was using my test pattern generator. So it's curious.
Never harmed anyone, never hurt or injured a fellow man.
I don't think the set has
You have the right to choose the way and
a
manner.
power line filter. No, I could try putting a safety cap across the AC line. Maybe I'm picking up some noise from the AC line. I could try turning off all the lights, including the fluorescent lights, see if that makes any difference. That's easy enough to do.